5.1 Operations of Polynomials. This lesson is really all about powers and all the rules of powers, how to simplify powers. So let's go over some. So the product rule, product of powers, so we should know that, right, if you multiply two things of the same base, you just add the powers. So like they do here, 3 squared times 3 to the 4th is just 3 to the 6th. Or b squared times b to the 9th is just b to the 11th. If you divide, you subtract the powers, top minus bottom. If it's a negative exponent, this is an important one. Those are like, you've done those before. Negative exponent is kind of new. A negative exponent flips the power. So if you see right here, x to negative a, it's just 1 over x to the a. And if you have 1 over x to negative a, it flips to x to the a. So I want to talk about this a little bit more. Get some space somewhere. So let's say I give you 2x to the negative 3. So what happens here, a lot of people do this. And that is wrong. If you notice, only the x has a negative power. 2 has its own power, it has the power of 1. We get this thing, 2 over x to the 3rd. And that's how you write it. And by the way, you could flip it and make it negative if you need to. So if you have 3 over, I don't know, x to the 4th, and we want to bring this x to the 4th up for some reason, you can make it 3x to the negative 4. So it works both ways. You can flip it and make it negative, or if it's negative, flip it and make it positive. So that's what negative exponents do. Power to power, so again, there's a big difference here, right? So x squared times x cubed is x to the 5th. But x squared to the 3rd power, that's x squared times x squared times x squared. So you multiply the powers, x to the 6th. Right, so power to power you multiply. And here's a rule everyone wants to do. X, y to the a power, you just distribute. Keep in mind that only works when it's a power. So like this is okay. That's x squared, y squared. This is not okay. If you put a plus or minus in there, and then that you're stuck. You can't do anything. Can't cancel out, can't make it look like this. It's not x squared plus y squared. This is wrong. You have to actually multiply it out. So you can distribute as long as there's not a plus and minus. And same thing with power over quotient. You could distribute it as long as it's not a plus or minus in between. And then there's 0 power. Anything to the 0 power except for 0 is 1. Okay, a couple things. I want to talk about simplify. When I want you to simplify, there's a couple things I want you to do. First, there should be no power of powers. I think that's kind of obvious. You can't leave it like this. That's not simplifying. Each base appears exactly once. What does that mean? If you have x squared times 2x to the 4th, you're like, wait, I could combine these. That's what that means. All fractions simplest forms. Here's the big one. It's probably kind of new. No negative exponents. If I give you this, you're like, whoa, can't have that y negative 1. We want to move that up. So no negative exponents. I think the rest are fairly obvious. That one's the only one. We don't. If we want you to simplify, we generally don't want negative exponents. Okay, let's do some examples. So this first one, notice we're just multiplying. There's no plus or minus. We're just going to multiply like terms. We're just going to multiply, sorry. So I get negative 8. A's. Now you just kind of count how many A's you have. I have 5 A's. So it's A3 plus A2 if you want to think about it the long way. You don't have to do all the work though. And then do the B's. B to negative 2 plus the 4. So again, negative 8, A5, B squared. And again, for short, just count how many of those things you have. Right? I'm like, okay. 2 times A is negative 8. I have 3 A's plus another 2. I have 5 A's total. I have negative 2 plus 4 is 2. No negative exponents, so we're good. This one, right? So I always like to do let's separate them out real quick. I like to do the numbers and variables separately so I can kind of see it a little better. So 12 divided by 2 is this 6. x4, x, you could do the proper way, which is you subtract x4 minus 1. The same thing here, you go y2 minus 5. You get x3, y to the negative 3. Then you got to flip this one. So you get x3, y cubed. You could do it that way. But honestly, the way I do it is I just kind of think of which one has more. So you look at the x's, you go, which one has more? The top has more, has 3 more. So it's going to be x3 on top. Look at the y's, which one has more? The bottom has more, but how many? 3. So it'd be y cubed on the bottom. So it works either way. Again, the way this works, the reason this works is you have 2 y's on top and you have 5 y's on the bottom. And then 2 are going to cancel out. So it's just like, oh, which one has more? If I'm doing the next one, I could distribute that 3 to everything. So it's going to be 2 cubed a6, 3 cubed b cubed. I get 8a6 over 27 b cubed. Same to the next one, that 3, so distribute it to all of it. So I get 6 cubed g to the 15th power and h to the negative 12 power. A couple things I gotta do here. Gotta flip this to the bottom because it's negative. And I gotta simplify that. So that's 216 g to the 15th all over h12. Next one's like expansive. There's like all this stuff's going on. Alright, so let's simplify the top first. 2 times 5 is 10. Look how many x's I have. I have x4, x5, so I have 9 x's in total. y2, y6 is y8. I have 8 y's in total. All over 20 x cubed y5. Right, now we simplify. Let's do the numbers first. 20 over 10 is just 1/2. 1 on top, 2 on the bottom. Then let's do the powers. Remember, I just like to look at which one has more. And my x's, I have more x's on top by 6. And on my y's, I have more y's on top by 3. And there you go. 1/2 x6 y cubed. So that's how you simplify. Let's talk about a little bit more about what a polynomial is. A polynomial is an expression where every exponent is a whole number. So you can't have no negatives, no fraction or decimals. Powers. Again, I only care about the powers. And actually I only care about the powers for variables. That says variable power. So that's all it means. So if you want a polynomial, those are the nice ones. So a polynomial is something like 3x squared plus 2y. Right? No negative powers, no fraction powers, no decimal powers, just nice powers. Now again, all I really care about is the variable. The numbers can be anything they want, but the variable is what I care about. It's like this first one, yeah, that's a polynomial. They want the degree. The degree is just the highest power. So the highest power I see here is 1. So the polynomial degree 1. The next one, again, all we care about is the variables. Those are all nice powers, so it's a polynomial also. And the degree is, look at the highest power. Degree is 2. Now let me rewrite this one because I have that fraction, that 1/2 right there. So this is x squared plus x to the 1/2. Square root is the 1/2 power, and that is not a polynomial because of the 1/2. And the next one, look right here. These are on the bottom, and on the bottom means they're negative powers because they're on the bottom. So not a polynomial again. Now let's simplify some polynomials. It's pretty straightforward. And then we're going to name the highest degree of each. So for this first one, let's distribute this negative. So we're going to get x squared minus 5x plus 2 minus 3x squared minus x plus 1, right? Distribute the negative. And then all we do is add up like terms. So I can add the x squares together, because they're both x squares. I can add the single x's together. And I can add the numbers together, the constants together, plus 3. So that's me simplifying the polynomial, right? Distribute, and then add like terms. Highest degree is this, the highest degree is this the highest power, so 2. Next one, same method, we're just going to add like terms. And I get that. Highest degree is 1. Next one's multiplication, so we're going to distribute. Now you just distribute like we always do. So 2a is 8. A times b is ab. And then 2a times 5 is 10a. Now this one we got to talk about, the highest degree. So in this case,
The degree here is 1, the degree here is 1 and 1. How do we treat when there's two variables? Well, you add them up. So this has a total degree of 2. So my highest degree here is the 2. Because there's the a and a b and they both have power of 1. So that's the way it works when there's multiple variables on the same term. So that kind of leads into the next one, right? I want to do 3x squared. So we're going to distribute. 3x times that is 6x3y minus 9x cubed y squared. And then that's going to be 12x to the 4th y cubed. So that's its simplification. And then the highest power, highest degree, it's not the one in front, it's the highest power, which together this is what, 4, 5, and this is 7. That's a bad 3. It's even worse 3. It's a slightly better 3. 7. So that's the highest degree. My degree is 7. If I was going to rewrite this, I should go in proper order. So this should be first, second, and third. You always want to go down in order. Alright, little binomial expansion. We're going to distribute on these. So we're going to distribute. We don't FOIL in this class. So you go n times n is n squared plus 7n. And then you move on to the next term. Negative 9n minus 63. And you get n squared minus 2n minus 63. So my degree here is 2. Now the next thing, I don't think I'm going to do them all the way, but I do want to talk about how to do these. A lot of people mess it up. So the way we do this, and you have 3 things, you do it 2 at a time. Just think about like numbers, right? If I give you 3 times 2 times 5, you don't just kind of multiply them all together. You actually just do it. You go these, like, oh, it's 6, and then 6 times 5. Same idea here. We're going to multiply these two first. So a times that, 2a squared plus 3ab. And then you multiply b by all these. So plus 2ab plus 3b squared. This would give me 2a squared plus 5ab plus 3b squared. Right, so all of that is just this part, these two put together. I still gotta multiply by this thing. All we do is do it pairwise, do 2 at a time. Just like we multiply numbers, right? Multiply these two first and then multiply that by the answer. Same thing with these. Multiply those two first, then multiply this by the answer. And then from here, do the same thing, distribute. I guess I'll do it all the way. 2a times that to minus 2a squared y. Move on to the next one, multiply these by both. So plus 10abx, I'm running out of space, minus 5aby. I go down here. So then last one, plus 6xb squared. And then minus 3b squared and y. And they have no like terms, so that's just it. That's multiplying all that together. The last one, remember I just want to point this out again for the 100th time. The answer here is not this. That is not the answer. There's a minus in between. Right, there's a plus and minus in between. You can't just distribute. What you have to do is rewrite it. This is going to be 4n minus 5. Times 4n minus 5 times 4n minus 5. Only way to do it if there's a plus and minus in between. Very different if I gave you this. If I give you this, then yeah, just go ahead. There's no plus or minus, just do this. This, totally different. So you have to get that and then multiply it out like I talked about. But I won't actually do it. Okay, let's see what's next. Oh, we're almost done. Last problem. So what's the value? What value k makes this? So that's what right. Use our rules to do this. So first, right, let's look at this. We're trying to find what k is. Remember, when they're the same base, we just add the powers. It's just like if that's all you do here, right? Add the powers. It's like if I gave you x squared times x cubed. You're like, oh, x to the 5th. You just add them up. So same thing goes here. It's gonna be q 4k plus 5. Now, if you look at it, it's actually going to lead into something we're going to do later. Is that if you notice, these are both the same. So I'm just going to, what if I just solve the tops? To 5, not a j. Let me just solve it. Minus 5, minus 5. I get 36 equals 4k. Divide by 4. K equals 9. And that's the idea. That's this lesson.